Okay, if you are in 7 Excel, we are working from the Advanced 2 textbook. If you are in Math 8, we are working from the Course 3 textbook. We are doing lesson 7.4. Approximating square roots. And it can be found on pages 310 to 312. Okay. So this next part, it doesn't have much to do with square roots, but this is one of the 7th grade standards. You do need to know this material. So let's take a look. Natural numbers. Natural numbers are 1, 2, 3, 4, and so on. Okay. Whole numbers. Whole numbers include the natural numbers, but starts with 0. 0, 1, 2, 3, 4. Then we have integers. Integers. -4, -3, -2, -1, 0, 1, 2, 3, 4. So natural numbers are part of whole numbers, and that's part of integers. All of these are part of rational numbers. Rational numbers include positive fractions, negative fractions, positive decimals, and negative decimals. So natural numbers are part of whole numbers, which are part of integers, and all 3 of these are part of rational numbers. Okay, and then we've got this other group here called irrational numbers. Irrational numbers. Irrational numbers are non-repeating. They have non-repeating decimals. Non-repeating decimals, nor non-terminating. Okay, so irrationals are non-repeating nor non-terminating. What are some examples? Pi. Pi is a decimal. It does not have any repeating sequences. And so far as we can tell, it never terminates. The cube root of 7. Cube root of 7. Same thing, non-repeating, non-terminating. The square root of 2. The negative square root of 3. And -2 pi. So these are some examples of irrational numbers. And all of these numbers fall into a group called real numbers. Okay? So let's go through some examples. Let's go through some examples. The square root of 12. The square root of 12 is irrational because it's not a perfect square. it has it's non-repeating and non-terminating. So 12 is not a perfect square. Negative 0.25 that repeats. So this is a negative decimal, and it repeats. The 0.25 repeats. So this is a rational number. Why? Because the 0.25 repeats. It's a negative decimal and the 0.25 repeats. Negative the square root of 9. Negative the square root of 9 is going to be negative 3. Negative 3 right here. So negative 3, this is rational, and it's an integer, because the square root of 9 is equal to negative 3. And negative 3, right here, negative 3 is an integer and it's rational. Next, they give us 72 over 4. 72 fourths. Well, 72 divided by 4 is 18. So 18 falls right here under natural numbers and whole numbers and integers and rational numbers. So this is rational and an integer and a whole number and a natural number. It's all 4 of those. Why? Because 72 divided by 4 is equal to 18. And 18 is here in the natural numbers, the whole numbers, the integers, and the rational numbers. And last but not least, they like to throw this one at us. Pi. What is pi? Irrational. Why is it irrational? Because it's non-repeating and non-terminating. Non-repeating and non-terminating. So I'm not going to ask you to memorize this. I'm not going to ask you to memorize this, but you do need to have this available to you when you do your homework and when you take the quiz on Friday, okay? I'm not going to ask you to memorize it, but you should have it available to you. Okay, let's keep going. We have 2 examples to get through, just 2. Okay, in our first example, 71, sorry, 71. We need to find the square root of 71. And we need to do this and pretend like we don't have a calculator with a square root button on it that we can push, okay? So let's pretend that we don't have a calculator with a square root button on it, okay? So when I need to find the square root of 71, we're going to the basics. I know 8 times 8 equals 64. 64 is a little too low. So let's try 9 times 9. 81. Okay. I know I started with my whole numbers. I know that the square root of 71 is going to fall between 8 and 9. It's going to fall between 8 and 9 because 71 falls between 64 and 81. So my square root is between 8 and 9. My square root is going to be between 8 and 9. Now let's go to the tenths place. So I'm going to start with 8. And I'm going to start with 8.5 times 8.5 because this is in the middle and it'll show me whether I need to go up or go down. So I'm going to start with the middle. 5/10 is in the middle. So here I can use my very simple calculator that has the multiplication function only. 8.5 times 8.5 is 72.25. Okay, so the 8.5 is a little high. So this is too high. 72.5 is higher than 71. So let's go down to 8.3. 8.3 times 8.3 is 68.89. This is a little too low. 68.89 is less than 71. So let's try 8.4. 8.4 times 8.4 is 70.56. 70.56. So this is still, it's a little too low, but I'm only 44/100ths away from here because my next choice is 1 and 25/100ths away. So this is still a little too low, but it is the closest. 8.4 is the closest to the square root of 71. It is the closest to 71. Therefore, the square root of 71 is about 8.4. Because it's the closest to 71. So that's what we're doing. You start with the whole numbers, and then you're going to start working the tenths to figure out what is the closest. But life doesn't stay this simple, and the book likes to get more bang for its buck. And they like to throw a problem like this at us. Which is greater? The square root of 5 or 2 2/3? So whenever they're asking us to compare numbers, which is greater, which is less than, put them in order from least to greatest. Whenever they're asking us to compare numbers, the easiest thing to do is to convert to decimals. Because if you convert it to a fraction, then you have to find a common denominator, and it's a lot of multiplication. So convert everything to decimals. It's always the easiest way to go. So when they're asking you to compare decimals and fractions, or fractions or percents, or fractions and square roots, always convert to decimals. But that means this is kind of two problems. We need to find the square root of 5, and we need to convert 2 2/3 into a decimal. Okay, let's start with the square root of 5. Let's start with the whole numbers. 2 times 2 is 4. This is too low. 3 times 3 is 9. This is too high. So that means the square root is between 2 and 3. My square root's going to be between 2 and 3. Okay, so now we move to the 10th place. And I personally always like to start with 5/10 because it's in the middle. It'll tell me if I have to go higher or lower. So 2.5 times 2.5 is 6.25. Oh, 6.25 and 5. This is too high. So let's go to 2.3. 2.3 times 2.3 is 5.29. This is still too high. 5.29 is still too high. So let's go to 2.2. 2.2 times 2.2 is 4.84. 4.84 is a little too low, but we need to decide which is closer to 5. So 4.84, this is 1600ths away from 5, right? 1600ths. This is 2900ths away from 5. So this one is the closest. So this one is 2900ths away from 5. And this one's only 1600ths away from 5. This is the closest. So my square root of 5 is about 2.2. But we're not done because we need to figure out the decimal here. And this is 5th grade math. So my whole number, I'm going to leave my whole number and I'm going to convert this fraction. The numerator goes inside. The denominator is at the door. Add my decimal point and 2 zeros. 3 goes into 26 times. 18. Oh, look at this. It looks like I have a repeating 6. So 2 2/3. 2/3 is equal to 6600ths. So this is 2.6600ths. Now I can compare my decimals. Which one is greater? 2 2/10 or 2 6600ths or 2 6/10? Which one's greater? 2 6/10, right? So which is greater, the square root of 5 or 2 2/3? 2 2/3. So that's what we're doing today. That is everything we are doing today. We are approximating the square root. So we start with a whole number and then we start working our tenths to see which is the closest. And then we're going to be comparing. And when we compare, I think it's easiest to convert everything to decimals. Okay. You will have a few questions based on this. So make sure you've got this available. Okay. So that's what we're doing today.